This is our client auth end filter, more specifically the OpenStack identity implementation of our client auth end filter. The basic, I guess, functionality of this is that a user will grab an auth token from an authentication service. They'll authorize with them and grab an auth token that they'll pass through Repose. So the client will send requests through Repose to their origin service, and what Repose will do is it'll ask the authentication service, hey, is this token valid? And if it is, then Repose will pass that request on to the origin service. And I guess normal flow of an API will continue. Now, if the token is invalid, say it's expired, it's a bad token, like it's a malicious user or what have you, then Repose will kick it back to the requester with a 401. That is the two most basic use cases of this filter. Now, there are quite a few configuration options for this filter. Now, the ones that are required are defining the identity service. This is that external identity service endpoint that Repose communicates with. You configure it with admin user and admin password. Now with OpenStack identity, a service is required to have an admin user to validate tokens, to check to see if incoming tokens are valid within the identity service. And this is where you define it: the admin user, the admin password, and of course the endpoint for the identity service. So actually, all of its interactions are actually defined within OpenStack. Namely, post tokens, which is how Repose will retrieve the admin token so that it can make admin calls like validating a token, and get token/token ID, which is the actual validation call for an auth token. This is the call that we send to the authentication service to ask it whether or not a token is valid or invalid. Now, for the different configurations, say you want to check tenant validation for requests coming into your end service. Well, if tenanted is true, which is actually the default behavior, then the user has to configure client mapping. What this client mapping will do is that it takes a regex with a capture group and looks at the incoming URI and pulls out a tenant ID from that URI using the capture group within this regex. So say with this regex right here, incoming URI would look like this, and then blah. Repose will capture this value within the URI, and it'll ask, well, it'll check the validated token call to see if, hey, it'll actually be a two-step check where it'll ask the authentication service, hey, is this token valid, and does this tenant belong to the token that was validated? Now, if you have tenanted equals false, then this is no longer valid. All the auth end component will do is ask the authentication service if the token is valid, and it'll pass it through. Now, another issue if tenanted is true is, say, for your origin service, you have a management API, or you have management users or admin users who can make calls as one of your regular users, you can define service admin roles that can skip the tenant validation. So when we do a validate token call, roles actually comes back with this payload. This example doesn't have it, but role does it? Where?
Go down 5 within the user section.
Oh yeah. My bad. So yes. So roles comes back with the validate token payload. Now, if an admin user is making calls as one of the regular service users, they can skip the tenant validation check, because when an admin user validates as a token, they'll have all the roles associated with the role with that token, which might not match what the user is supposed to have, or it might not even have a tenant. If you can define this list of service admin roles where Repose will check that roles list that comes back with the tenant validation call, and if the token falls with contains one of these roles, it'll skip the tenant validation and allow the request through. Another way to get through things is, say you have a call for your API where a user can, I don't know, request the waddle for the API. You can actually define a URI whitelist pattern where no validation will happen whatsoever as long as the incoming URI falls within this URI regex. So things like application.waddle or asking for versions, or just simple information that you don't require any sort of authentication for, you can define here.
Does it still validate that the token is valid?
Mm-mm.
Or it bypasses the token check completely too?
Yeah, it bypasses off everything when you define this whitelist URI. What else? One of the other features of Repose is that it implements auth delegation, which is defined actually under Keystone middleware as well. So delegation happens when, well, if you turn on auth delegation, if a request comes in and contains no user credentials whatsoever, so in case of tenanted mode, tenant and auth token, or in non-tenant mode, no auth token comes in, then Repose will pass that request along and sets a header called www-authenticate and give it the value of delegated, which means that Repose, well, this passed through a authentication middleware, but since delegated was turned on, then we passed the request on because it contained no credentials. So authentication was delegated to a service past Repose. Another features of Repose is actually our cache. So say your service is a high volume service and users are passing tokens through, passing requests through at a rapid rate, well then Repose isn't going to flood the external authentication service with requests. It'll actually cache valid tokens for a certain amount of time. Now you can set the group cache timeout, the token timeout, and the user cache timeout. So the group cache is actually a Rackspace specific feature where Rackspace implemented an extension for the OpenStack identity service because they have values, well, they have users that fall into groups. And so Repose will cache groups for this many milliseconds at a time, and then it'll expire from the cache, and once that happens, it'll request against the authentication service again. And the same thing with the token timeout. So you pass a token through Repose, and it'll cache it for 60,000 milliseconds. And this also interacts with, say, if the identity service sets an expiration time for that token, it'll actually take the lower value of the two tokens. So say you set this token cache timeout to well, 60,000 milliseconds, and that initial token that comes through Repose, it comes back and the identity service says, hey, this token is only valid for the next, I don't know, 3,000 milliseconds. Well, Repose won't cache it for 60,000 milliseconds. It'll actually only cache it for 3,000 milliseconds, because the identity service is the authority on all user and user information. And
is that cache a local cache or a distributed cache?
It's a local cache. So none of the authentication, so if you have a Repose cluster set up, then none of the authentication stuff goes through the wire at all. And same thing with the user cache timeouts. Now, a feature within these is called the cache offset. So say you bring a Repose node up into rotation, and suddenly a Flutter request comes in. Well, if you set the token cache timeout to, say, 60,000 milliseconds, all those tokens will expire within 60,000 milliseconds. And what's bad is that after those 60,000 milliseconds, well, then suddenly, like every 60,000 milliseconds, you're going to flood the external authentication service with requests, because all those tokens expired at that time. Now, over time, it'll probably normalize, but a lot of times that initial period will actually be bad for the external auth service. What the cache offset will do is you give it a seed, say, I don't know, 5,000 milliseconds, and what it'll do is it will add or subtract that value to the cache timeouts for any of these things. So say you set the token cache timeout to 60,000 milliseconds. Well, it could be cached from anywhere between 55,000 milliseconds or 65,000 milliseconds, so that you have that. So you have a more random distribution of cache timeouts, so that not all your cache objects will expire at the same time. Now, speaking of cache tokens, the Repose auth n component also has an ability to check atom feeds for invalid or invalidated tokens or invalidated users. So what you can set up is for Repose to check one atom feed or multiple atom feeds to see if users or tokens have been invalidated. So you can set up one with that is auth or unauth. So some feeds are auth the same way that Repose is auth, using the identity service contract. So if isAuth is true, it'll actually use the credentials set up here to retrieve those event feeds. If not, then it won't send any credentials. It'll just retrieve those feeds and parse them for invalidated users and tokens. If it's a completely different auth system, or just a separate auth system than the one that Repose normally talks to, you can set a user and password and endpoint for it as well. But it has to also adhere to the identity service contract. And the last setting is how often Repose will pull these feeds for invalidated tokens and users. So in here, it's every 60,000 milliseconds that it'll pull these atom feeds saying, hey, are there any invalidated tokens or users that have been reported recently? This other feature, endpoints and header. So say the end service requires the list of endpoints that's associated with a user. That list of endpoints is, well, the format for that message is defined by the OpenStack Identity API. So it will be this payload. So endpoints links for users. So
and is this that's the same response that we get in client authorization too?
I thought that was used in client authorization.
Yes, and that's right.
But I was wrong.
yeah. So
It's not.
in the auth component, it does the same call,
Yeah.
but it parses it and puts those and uses those endpoints to do the auth check. This is simply retrieving that information from the external auth service and putting the payload into a header.
Oh, I see.
And I think it's a base64 encoded
Yes,
header.
base
Yes.
64 code. Yeah, I thought that it needed client auth and you get this information and then it did a comparison. But in fact, when client auth Z does a call, it gets this, but it doesn't put it in the header or anything like that. And then it does a comparison against something else and then it picks it up.
Yep. So this is simply taking the payload from the external auth service, which is this JSON payload right here, and put base64 encodes it and adds it as a header. Yeah.
Do we also cache that? We
I
have a cache
believe-
timeout.
Yeah, I believe we do. Not 100% sure yet. Yeah, actually, yeah. My bad.
So we do.
Yes.
So if we cache that from client authentication and then client authorization was added in the filter chain,
No.
would it look at the cache value?
Mm-mm. No, because this caches the raw response from the identity endpoint. The auth component unmarshals or marshals it to a Java object and caches that
Okay.
into its cache. So it's two separate things. But we could probably make it so that it looks into the auth component looks into that other
Like
cache.
the feature optimization, if you've got both anyways, why make two calls?
Yep, exactly. Okay, and I guess that does it for.
Did you cover that request groups attribute?
Oh yeah, sorry. So this component was originally designed to work against the Rackspace implementation of the OpenStack identity contract. But the Rackspace implementation included a groups extension, one that matched against some kind of user group that the internal Rackspace system used. Well, since this is technically supposed to work against identity, OpenStack identity implementations, you can turn off that request groups because it's another call against the external auth service where it'll say, hey, what's this user's groups? But turning this to false will turn off that extra call, so you no longer have to worry about that. Or if it's not a concern, then your service doesn't have to worry about that. Now, there are failure scenarios for this filter. So this filter interacts with an external service. Well, sometimes the external service might be down, or it's being flooded, or what have you. So if, say, Repose receives a 400 from a validate token call, then we'll return a 500. Say Repose's admin user has been compromised, and identity no longer recognizes that user as valid and returns back to us a 401 on any of our calls, we'll return a 500 back to the user that requested against Repose. Basically, we'll return 500s in most error scenarios because that indicates a problem within the stack that between the service stack that Repose represents. So if Repose is the external facing stack, then the customer doesn't know anything about anything behind Repose. So if anything goes wrong within those exchanges, then it's a 500 to the user. It's a 401 to us or 429 to Repose, but to the user it will be a 500. The only time that it'll be an error response code from the external identity service to Repose will cause a 400 error is if the identity service returns back a 404, which means that the token that was sent to Repose was invalid.
Did somebody just change that wiki page?
Yeah, he sorted.
Oh, okay.
Say what now?
Yeah, it's invisible, but you actually can sort by those columns.
Yeah.
And you
Sorry.
clicked on one and you got sorted.
Oh, I'm sorry.
You blew our mind, man.
Yes.
Tiny little up down arrow.
Yeah. And yes. And I guess that's it. So I guess one thing that I missed was that Repose will append a lot of identity headers to request once it's validated a token. Things like X authorization, X identity status, confirm or indeterminate. Indeterminate will happen if delegation happens. So if Repose is in delegable mode and a request passes through because it didn't have any credentials, then Repose will set the X identity status to indeterminate. And if validation is successful, it'll set X tenant name, X tenant ID, X username, X user ID, which all calls back to this payload. So user, tenant name, tenant ID, things like that will just be represented as X dash and then something. I believe that's it for this component.